So like we previously talked about, if we go and we have opposite magnets, so opposite magnetic fields, they go and they attract each other. Like magnets will go and repel. Right. One easy way that we can go and show this is if we go and balance the magnets on these turny things, they will always go round. So if you turn one, that magnetic field will go and interact with that magnetic field. So it's always going to go and try and attract that opposite end of the magnet. So north is always going to go and try and attract to south. So if you went and spun this round kind of gently, so you're always going to have that north going and attracting the south. Right, and you can have lots of uses of this. Right, in certain train systems, so especially in Japan, they've got trains that go and levitate in the air because they sit on magnets. The way that this happens is if we use this, you go and have an alike against an alike, which goes and causes, because that magnet above it is being repelled by that magnetic field, that magnet there technically is being held up there by that magnetic field because they're repelling each other, which causes them to float in the air. Right, and the magnetic field is going and holding it up. So one use of this, like we talked about, was if you had some sort of train that was going to go, so if that's our series of magnets, so we've got, let's say they're all south facing, right, and we've got magnets on the bottom of the train, which are also going to be south facing. So we go and we put our train above it. Very rough, but so now that train is technically floating on almost like a bed of magnetism. So if it's not physically touching the ground, that's going to reduce the friction. If we reduce the friction, that means that the train can go and move quicker. Also, it means that it's going to use less energy to go and move forward because there's no friction slowing it down. So that's just a few more properties about magnets.